This is number 3a, which is asking to find the values of f of negative 6 and f of 5 using the graph of f prime, given that f of negative 2 equals 7. To start off solving this, I'm going to use the fundamental theorem of calculus, which says that the integral from a to b of f prime of x dx equals f of b minus f of a. So since we're already given a value of f of negative 2, I can actually use that for our value of a here to rewrite our fundamental theorem of calculus as f of x, x being the value we're solving for, so negative 6 and 5, equals the integral from negative 2, that's our given value, to x of f prime of t dt plus f of negative 2. No, all I really did there was just bring the f of a over and change the b to an x, because that's what we're solving for. We're solving for f of b now, or f of x. So now I can just plug in my values for x and solve. So f of negative 6 will equal f of negative 2. And since negative 6 is less than negative 2, I'm going to make the integral negative and switch the bounds. So it'll be minus the integral from negative 6 to negative 2, f prime of t dt. So to find this integral here from negative 6 to negative 2, we need to solve for the area of this triangle right here. So we have a base of 4 and a height of 2, which will give us an area of 4. So f of negative 6 equals f of negative 2 is 7 minus 4, which will equal 3. And now to solve for f of 5. F of 5 will equal f of negative 2. Since 5 is greater than negative 2, we don't have to make the integral negative. So f of negative 2 plus the integral from negative 2 to 5 of f prime of t dt. And to find this integral now right here from negative 2 to 5, we're going to have to find the area of this semicircle right here and this triangle right here. So the semicircle, if it were to be a full circle, it's only half of one. Since it has a radius of 2, it would be 4 pi. But since it's only half a circle, we can divide that by 2 to get 2 pi. And since it's below the x-axis, it will actually be negative 2 pi. And this triangle right here has a base of 3 and a height of 2, so we get an area of 3. So f of 5 will equal f of negative 2, which is 7, minus 2 pi plus 3, which equals 10 minus 2 pi.
So for this problem, I'm doing B, and B asks, on what intervals is f increasing? And then justify your answer. So for this, we have to use the fun chart. So okay, so since we're given the graph of f prime, and we need to figure out when f is increasing, we just have to look at the chart. So f is increasing when the graph of f prime is positive. So looking at the graph, we need to find all the points, not all the points, all the intervals when f prime is positive. So f prime is positive from negative 6 to negative 2, and then from 2 to 5. Those are the only intervals when f prime is positive, meaning that f is increasing on those intervals. So going back to here, what we have to write is, well, first from -6 brackets -6 to -2 and 2 to 5. And then we use parentheses here because the value can equal 0. So our justification for this, it's going to be that f is increasing on -6 to -2 and 2 to 5 because f prime is greater than 0, or in other words, it's positive on those intervals.
I got question C, which is find the absolute minimum value of f on the closed interval from -6 to 5. Okay, so first, in order to figure out what the x value is, we have to find the critical values, which is where f prime equals 0 or does not exist. So that is at x equals -2 and x equals 2. And then we also have to test out the endpoints. So the endpoints would be x equals 5 and x equals -6. So the points we have to test are x equals 2, x equals -2, x equals -6, x equals 5. So we are already given f of -2. F of -2 is going to be 7. So we can use that to find our other values. So first, we'll find the value of -6. So we use the integral of x prime of x dx from -2 to -6, and that is equal to f of -2 minus f of -6. We can already plug in f of -2 as equals 7, and that means that f of -6 is equal to the integral minus 7. So now we have to find the area from -2 to -6 on this graph of f prime. So we can do 1/2 base, which is 4, times the height, which is 2, and we would get 4. So we would plug that back in. You get 4 minus 7 equals negative f prime. F of -6, negative f of negative f of -6. So -3 equals negative f of -6, and the negatives cancel out, and f of -6 equals 3. So when f of -6 equals 3. Next, we're going to find the value of 2. So we make another integral. The integral of f prime of x dx from 2 to -2 is equal to f of 2 minus f of -2. Now we already know what f of -2 is, and that is 7, so we can just put it to the other side. So now what we need to do is we need to find the area from -2 to 2 on our graph of f prime. So this semicircle. So the formula for a semicircle is 1/2 pi r squared. The radius is going to be 2. And our area would come out to be 2 pi. But since it's under the x-axis, it has to be -2 pi. So then we get -2 pi plus 7 equals f of 2. So f of 2 equals -2 pi plus 7. So now we have to test out our last value, and that is going to be x equals 5. So we'll plug it in again to our integral. F. We can automatically plug in the 7 for f of minus 2, or f of negative 2. Okay, so now we need to find the area of minus 2 to 5. So we know that this area right here is going to be negative 2 pi. So now we need to find the triangle. What is this value right here? So it's 1/2 base times height. So 1/2, the base is 3, the height is 2. So it is minus 2 pi plus 3. So I have to plug that area in for this integral here. Minus 2 pi plus 3 plus 7 equals f of 5. Then we plug in f of 5 again. And we get minus 2 pi plus 10. So f of 5 equals minus 2 pi plus 10. The absolute minimum is going to be f of 2 at minus 2 pi plus 7 because that's the lowest value.
So the second problem I'm going to be doing is D. So D asks for each of f double prime of negative 5 and f double prime of 3, find the value or explain why it does not exist. So first we'll find f double prime of 5. So f double prime of 5, if we look on here, since we do have the graph of f prime, and to find the f double prime, all we have to do is find the slope, because that's essentially what the derivative is. So to find f double prime of 5, that's right here, so that means we need the slope of this point and this point. So the first point we found was negative 6, 2, and the second one is negative 2, 0. So all we have to do is apply the slope formula. So that's y2 minus y1 over x2 minus x1. So all you have to do now is plug in. So 0 minus 2 over negative 2 minus negative 6. Then that's negative 2 over 4, which is equal to negative 1/2. So f double prime is negative 1/2. Now we need to find f double prime of 3. So if we go back here, f double prime of 3. We see that these, well, first of all, the point 3, 2, it's at a corner, meaning it's not differentiable and you can't find the derivative at that point. So to prove this, we have to use limits. So first we need to find the left-hand side, and then we need to find the right-hand side. So the limit as x approaches 3 of f prime of x minus f prime of 3 over x minus 3. Okay, and then what we need to do is, this is the how we're going to find it. So once you apply the formula, you get the limit as x approaches 3 from the left of f prime is equal to 2, because 2 over 1 is 2. And then the limit as x approaches 3 from the right of f prime of x is equal to 1 because it's 2 over 2, the rise over run. And if you plug your numbers into the formula. So now that we have that, we have to justify. So f double prime of 3 does not exist because the limit of f prime of x, the limit of f prime of x as x approaches 3 from the left does not equal the limit of f prime of x as x approaches 3 from the right.